Welcome to Data Skeptic. Data Skeptic brings you discussions about how data is changing our world. Our interviews are conversations with thought leaders in topics like data science, machine learning, and artificial intelligence.
Happy almost New Year, Data Skeptic listeners. As this airs, Linda and I are doing our best to tidy things up at Data Skeptic HQ and prepare to very literally begin a new chapter here on the show and on the website. We're winding up our series of episodes on the theme of computational complexity theory, and now we're diving headfirst into our new theme, artificial intelligence. In this episode, I'm going to talk a bit about why we're doing that. I'll share a few details on things we'll be covering. I'll overview the main thesis of the show for the next few months, and the core questions and skeptical talking points that we'll need. To begin with, let's talk about where AI overlaps with core topics we typically get into on the podcast, like data science and machine learning. AI, ML, and data science, all three of these are adjacent areas of study with very blurry borders between them. The podcast will be covering a lot of topics in those blurry areas. The very broadest Venn diagram of AI would include certain aspects of economics and philosophy. We're not likely to touch on things like that. My core interest is in the methods, algorithms, and datasets that are used in pursuit of artificial intelligence. You'll find that our mini episodes focus on techniques, and our interviews will focus on people developing, deploying, or criticizing those techniques. If you're looking for artificial intelligence discussions that might be labeled as futurism, look elsewhere. I could never fault a person for being speculative, but I'm of the opinion that no one has the roadmap to artificial general intelligence. That being true, it's rather uninformed for people to have extremely strong opinions about AI. Assigning dates to things or proclaiming that human extinction is inevitable are points of view that should rather obviously demand our skepticism. Now, that doesn't mean I can prove to you that artificial intelligence will not emerge, enslave humanity, and then destroy the planet. I suppose that's a possibility. But for me, some of these discussions are a bit like the Wright brothers worrying about how to support in-flight Wi-Fi. I also don't mean to trivialize the topic. Automation and machine learning in warfare is a pretty scary topic that needs to be taken very seriously. We may touch on that this year, I'm not sure yet. So how do we have intelligent discussions about artificial intelligence in the current day and the not too distant future? Well, it's a complicated topic if you ask me. It's one deserving of a whole series of episodes, and so begins our foray into AI. This show will continue on otherwise in its normal format. Weeks will alternate between mini-episodes providing a high-level overview of topics where we try to give the listener a high-level sense of what the topic is, how it works, and why it's important. Our interviews will be with people doing interesting things related to the field of AI. In addition to that, a few more polished and produced episodes might just slip into the feed unexpectedly. That's entirely thanks to the generous Data Skeptic members who visited dataskeptic.com and chose to support what we do. We can't thank our supporters enough. Every dollar is reinvested in the show, and I think you'll start to see dividends on those investments this year. So to kick off our run on AI, it seems like the first question to ask is, what exactly is artificial intelligence? You know, if you ask me, that phrase is kind of bankrupt. The marketing departments of many corporations would have you believe things as simple as keyword matching are artificially intelligent. Of course, that isn't to say that every claim related to AI is propaganda and alarmism. We can draw a few fair comparisons between artificial intelligence and nuclear power. Both require the brightest human minds to develop. Both will demand long page counts in the history books of the future. Both have the potential to do tremendous good and tremendous harm. Although we should be much more specific about exactly what harm is plausible from AI. I'm not the first person to ask the question, what is AI, and not be totally prepared to answer it. I remember being at a lecture in grad school that I want to tell you about. This was ages ago, and I'm sure everyone knows that human memory is fallible. There's a small chance I have the speaker mixed up, but as memory serves, it was Pete Nelson. He's now the Dean of the College of Engineering at the University of Illinois, Chicago. Pete, if this gets back to you, please forgive me for stealing your story, but I couldn't think of a more eloquent way to ask the question, what is AI? So as memory serves, he shared a story of an earlier time when he was presenting in front of a group including John McCarthy. John McCarthy is regarded as one of the founding fathers of artificial intelligence. Pete's slides were, as I recall, about his research into traffic forecasting using neural networks. And 3 to 4 slides in, had a slide, as one often puts in a lecture on AI, asking the question, what is AI? Most lecturers give a very hand-wavy answer or mumble something about Alan Turing. I've been to a lot of lectures like that. Including a slide asking, "What is AI?" seems to be a formality that many people are compelled to include and then try to move past quickly. John McCarthy, as would be his privilege to do, derailed the lecture and turned that slide into a jumping-off point for a 45-minute discussion on the matter. Perhaps the lesson is, be careful what you put in your presentation slides. But let's also take note of the fact that a room full of great thinkers on the topic took at least 45 minutes to answer that question, assuming they got to an answer at all. It's a fun story, but my absolute favorite aspect of this story is how it itself is sort of a magic trick. We reached the end of the story and it feels satisfying, yet most of you failed to notice that once again I asked the question, "What is artificial intelligence?" and I managed to dodge answering it. I'm not the only one who does this. Definitions of AI can sometimes seem to be moving goalposts. You don't want to define something that isn't complete enough. As soon as anyone says, "A computer will never blank," we seem to have new computers blanking within 18 months or so. Perhaps AI will emerge in a way we don't expect. People often review what the past thought the future would look like and say things like, "Hey, where are all the flying cars?" That has always puzzled me because from my point of view, we have them. They're called helicopters. So maybe asking what is AI is a somewhat ill-defined question, like asking, how much money do you need before you're considered a rich person? Okay, take whatever number that is and subtract $1. Is that person still rich? But we really ought to have some answer here, so I'll try and answer it two ways. First, in a way mostly meant to be exclusionary, kicking out the marketing hype and including only the things that seem like good techniques or worthwhile paths towards AI. I'm going to give a certain definition here. Anything that is a legitimate, autonomous decision-making system falls squarely into the domain of AI for me. Such a system would have sensors or inputs of some kind. It would independently formulate a decision and then execute actions in pursuit of a goal. When research techniques fit that model, I'm perfectly fine calling it AI. When products do something like that, sure, call them AI. Do not call them artificial general intelligence, but AI, fine. My definition obviously and rightly includes self-driving cars, but technically also includes thermostats. What I've just described is usually referred to as the agent model, and we'll cover that on our next mini-episode. Other important topics that I'm fine labeling AI include knowledge representation, probabilistic reasoning, planning, and learning. I have a special interest in planning. By the end of this series, astute listeners are going to be well prepared to talk about things like partially observable Markov decision processes or POMDPs in casual conversation. Now on to the strong definition. Let's imagine a machine is presented which claims to possess this quality of artificial general intelligence. How will we test it and evaluate this claim? To answer that question, we're going back to 1950 and rereading Alan Turing's classic paper, Computing Machinery and Intelligence. I'm going to take for granted that listeners know what the Turing test is. So why did Turing think that conversation was the right evaluation criteria? Turing did not suggest chess playing or Go playing, despite knowing about both of these games. His tragic death occurred long before IBM's machine called Watson competed on Jeopardy! While that did use natural language, it's a far stretch from a legitimate Turing test. So look, IBM did great work on that. Round of applause. I wish they hadn't taken to labeling everything they do with the Watson brand, because I find that deeply confusing, seeing as how many of the things that today are called Watson have seemingly nothing at all to do with the Watson system that competed on Jeopardy! But seriously, great incremental work on their part. Should we call it a stepping stone? To be honest with you, I don't know if that's a meaningful question. Was the invention of the arrowhead a stepping stone to the invention of the smartphone? Watson did not, and wasn't attempting to, pass the Turing test. And the Turing test is not some arbitrary idea. There are deeply meaningful reasons why Turing picked language, and we'll get into that in future episodes. Whether or not we call Watson a stepping stone, we're going to cover and celebrate many of these so-called stepping stones, but we're not going to refer to him that way, because we frankly don't know if these things are stepping stones or not. When it comes to the core conjecture, it's all about the Turing test. Like I said, we're going to do an entire episode on just the test, so I won't go into too much more details here. But I do intend to reassure you that it is the proper test. It would be easy for someone looking at this show on our site and the past things we've covered to say that we are going to be a pro-AI podcast. There have been many noteworthy results that have come out in the last several decades from people that call themselves AI researchers, I've had the pleasure of interviewing many of them on the show. That's going to continue to happen. There's great work going on, and we're going to celebrate that. But there's also no shortage of ways in which we can emphasize the skeptic in Data Skeptic while exploring AI. A skeptical point of view has to start from the default position. Either artificial general intelligence is possible, or it's not. Which is it? Some default positions are easy to work out. Bill Clinton is either a shape-changing lizard creature or he is not. That doesn't make it 50-50. The default position on AI is admittedly not as clear, but we'll come back to that in a bit. First, where is the burden of proof? To answer that question, we have to precisely define the claim. So I'm going to throw out a series of claims and then discuss the skeptical perspective on them. Claim number 1. Artificial general intelligence is not possible. Machines cannot possibly replicate the human activity we call thinking. This is an assertive claim, and thus demands evidence from the claimant. Although I've heard dozens of reasons why AI is impossible, I'm yet to find any of them remotely convincing. Human beings exist, and we all agree that everyone thinks, or at least most of us. Our bodies are biological. Our brains are composed of neurons and other things. All of our components obey the laws of nature. Our brains can be described as meat machines, or more simply just as machines. They're complicated and wonderful machines for sure. Machines that we don't fully understand. Machines for which many wonderful things are yet to be discovered in the future. But saying that our brains do something that no machine can do is akin to saying physics is wrong. If you didn't catch my interview with Scott Aronson last year, I would highly recommend you go back to it. Scott and I did not talk about artificial intelligence, we talked about quantum computing, and although there are people who would draw a link between these two topics, I don't necessarily know that there is a link there. I'm reminded of something he said because I feel like it's analogous to a statement I can make about AI. Quantum computers are in the news a lot these days. You should be very skeptical of the hype. It's very difficult to build a quantum computer, and we're a little ways off from it. A large-scale one, that is. At present, one could say that a fully realized quantum computer exists on paper. The only challenges are the engineering ones. If we could trivially supercool things to almost 0 Kelvin and keep them there, and do that without a huge energy cost, we'd be a heck of a lot closer to a useful quantum computer. That cooling process is a purely engineering challenge to some degree. While obeying the known laws of nature, engineers will have to explore different techniques, approaches, materials, and strategies to deliver quantum computing beyond the toys that exist today. And as Scott so eloquently pointed out, if you want to prove quantum computing is impossible, you have to introduce new physics. And that's super awesome. If you can do that, great. Maybe the same thing will happen with AI. I believe the analogy is true there as well. If you think that a machine can never do something your brain does, then the burden of proof is on you to state what that mechanism is, and why no human-constructed machine could simulate or replicate that mechanism. There's been a few attempts to do just that. Sir Roger Penrose is probably the most well-known example. He has this idea about microtubules. I'm not sure if we're going to get into that in future episodes, but if I feel obliged to point at one argument, even though I don't find it credible, I think that's the one. Alright, claim number 2. AI can happen with all the current technology just scaled up. The backpropagation algorithm has been known for decades. The set of methods we now call deep learning are just the same basic ideas massively scaled up. Today, researchers can affordably gain access to an amount of computing power that would seem like science fiction to the people who started thinking about perceptrons. It's important that we don't make a mistake here. It's not like these ideas stagnated in old journal papers until overnight a few years ago people started bringing these methods back. There's been a long series of advancements and discoveries in a sequence, albeit with some recent locally exponential growth. These things weren't popular for a while, now they're immensely popular. I don't want it to seem like I'm not aware of the hard work that many people have done over the years, but basically, old ideas scaled up is an overgeneralization, but efficient summary. We took those old ideas, simple ideas maybe, and exploded them into facial recognition, voice recognition, near human level language translation, better than human level diagnosis on some medical diagnosis tasks. And as mentioned, we're at the very first stages of self-driving cars that rely heavily on these technologies. Are there limits to just how far these applications can scale? Is it inevitable that artificial intelligence is just going to fall out of a trained neural network between learning iteration 56,525 and learning iteration 56,526? Huh? When you phrase it that way, it sounds somewhat ridiculous. But extend the idea to human child development. They come out with a rudimentary operating system, but most of the software takes years to install. I keep waiting for my oldest nephew to learn about matrices, but we're not quite there yet. Data Skeptic has covered the topic of the limits of deep learning. Just this last year, we talked to John Wilms about his paper on the complexity of learning neural networks. This paper defined a very simple mathematical function, family of functions rather. Functions from this family are just mathematical functions that can be created by hand by a human being and constructed to actually be computed by a neural network. They present a proof, though, that no neural network can efficiently learn those functions from that class. Interesting, so even though the neural network could be the function, it could exactly describe it, it could never efficiently learn it. Back in 2015, I interviewed An Nguyen about his paper, Deep Neural Networks Are Easily Fooled. His work continues earlier work on this topic of fooling images. You guys have seen this stuff, for sure. There's tons of examples on the internet of, like the image of a panda recognized both by our eyes and by a trained neural network as a panda with high probability. Then there's a very subtle amount of strategic noise is added to the image. The resulting manipulated image still looks like a panda to human eyes, but the neural network thinks with high probability that it's, the ska band Big D in the kids' table. An's paper showed that you could construct images that look more like abstract art to the human eye, but do a great job fooling networks as well. The fooling images literature is growing, and there's a lot I haven't had time to consume yet. Although one interesting aside, there was a poster at NIPS. I apologize for not knowing the presenter's name off the top of my head. If you're the presenter, send me an email to kyle@dataskeptic.com, and I'll find a way to make it up to you for missing the reference here. I enjoyed our conversation that night. This poster basically showed they want to introduce JPEG compression to the stream of images. And they showed that just doing that, compressing it and then uncompressing and analyzing it, that was highly efficient at mitigating the fooling attacks. It's not a mic drop, but it's a noteworthy mention on this topic. Anyway, both of those episodes explored the limitations of deep learning. Although, whether or not these observations present a deep neural network from emerging into something we call artificial general intelligence is not clear. Geoffrey Hinton made some notable claims last year about the future of backpropagation and was the co-author on a paper putting forward the idea of capsule networks into the literature. Guys, I promise you we'll cover capsule networks. To be frank, it's still a very new idea and I don't understand it yet to the degree I feel comfortable presenting it on the show. We'll get to it, I promise, but I'm not sure when. But back to the claim that we have all the theory we need and it just needs to be scaled up to become artificial general intelligence. My belief is that this claim is false. I believe there are perhaps a half dozen more novelties that need to be created in addition to scaling out the systems. Now, my belief is one you should not accept outright. It's a point of view that requires evidence. And we'll get into some of that evidence here on the show and in the Data Skeptic blog this year. And while that might be my point of view on the matter, I believe this is an area for effective and interesting debate, so I'm eager to hear contrary points on that view. Okay, claim number 3. AI is inevitable and it will replace us. This is actually two claims. In many ways, disco was inevitable, but it didn't replace much. Debating about an AI nation state and how we might establish foreign relations with a breakaway robot colony is just bizarre to me. I realize I'm making a bit of a straw man argument here, but I just think it's preposterous to think we could speculate with any precision whatsoever about what a theoretical artificial general intelligence might theoretically think about humanity. Besides that, it's going to be entirely situational. If you want to do some daydreaming, ask yourself this. What if a civilization of very evolved Neanderthals was discovered today in some remote area? This is obviously impossible, but go with it. They're very advanced and intelligent. They've got good engineering, education, economy, etc., etc. What happens next? What sort of relations do we establish with them? Would they even want to talk to us? Would people be weird about interspecies love? Who knows? Being artificial would make a being special, but not that special. I don't know that such interactions would be any different from our hypothetical Neanderthal. But people seem to want to ascribe the idea of AI, especially an AI in a robot form, with some sort of superpowers, which, sure, maybe robots in some definition could actually have. But that doesn't make them invincible. Anyway, I don't want to get too far down that rabbit hole. mostly because I'm not that interested in this discussion, because I think it's all excessively speculative. The footnote I do want to attach, though, I think people should go to futureoflife.org/AI-open-letter and read the open letter, Research Priorities for Robust and Beneficial Artificial Intelligence. I do not want to trivialize the fact that AI, or the techniques we might call that, could today be deployed in military contexts. And regardless of your perspective on the rights and wrongs of that, I think we can all agree it's a discussion that needs to happen. But this isn't a politics show, or a foreign relations show, or anything like that. Those discussions need to exist elsewhere. So let's focus more on the AI is inevitable part of this claim. There's two ways to look at this. Maybe the brightest humans that will ever be are still not going to be clever enough to figure out all of the bits and pieces necessary to construct a machine in just the right way so that it can think. That doesn't preclude such a machine from existing, just that those little primates warming planet Earth up very quickly aren't going to be around long enough to accomplish the task. This could be. It's the much more threatening existential debate compared to the previous one, in my opinion. It's also a debate I'm gonna stay away from. I don't have the appropriate background to tackle claims in this area, but I believe this threat is worthy of discussion elsewhere. The other side of the AI is inevitable coin begs the question of whether or not we're even on the right path. Last century, some very industrious human beings built the first vacuum tubes capable of storing information and enabling us to compute. They moved on to punch cards, which were a bit better, but weren't going to scale without a lot of mechanical failure. Along came the transistor, and then we made it smaller and smaller and smaller and cheaper until they became these marvelous little machines that we take for granted on a daily basis. But of all these things that machines have done so far, demonstrating artificial general intelligence is not among them. Perhaps we need to scale in some way fundamentally different from how we build transistors. That is, if we take the human body as a blueprint to copy. We are self-manufactured creatures constructed in a way that doesn't remotely resemble the construction of a digital computer. Perhaps a revolution in design needs to occur. I mean, if we think of nature as an algorithm which evolves species, and we think of a species as a solution to the optimization problem of survival, then nature arrived at one particular solution in how we should be created. Sure, maybe nature got caught in a local optima, and maybe we can find some maximal point that's better on our quest to engineer life. But maybe we need a fundamental change in how we build it. I'm honestly not sure how I feel about that argument, but it's interesting to me. Claim number 4. The singularity is coming. I think the most outspoken person associated with this claim is Ray Kurzweil. Kurzweil is not at all someone you can immediately dismiss. He's a smart and accomplished person. However, that doesn't prevent him from also being wrong. I'm not saying that he is, per se, but I find a lot to be skeptical about in the ideas he puts forward. His claim that we are experiencing a double exponential of growth is something that, in one context, I know exactly what he means, but in the other context, the one he actually uses it in, I frankly have no idea what it means when I think about it deeply. There's a talk, and I haven't watched this yet, I really should have, but I'm down to the gun getting this episode out. I just found on YouTube, Ray Kurzweil, human-level AI is just 12 years away. Now, unless he goes into why that's a dubious claim, I'm just going to say it's a dubious claim. I will watch this video. Perhaps he'll change my mind, but 12 years is awfully soon. As skeptics like to quote, extraordinary claims require extraordinary evidence. So I would hope it's clear. These singularity ideas, in my opinion, require a very healthy dose of scientific skepticism. There's a lot of different interpretations of these ideas, but I think at the core they all share one common assumption. They assume that once artificial general intelligence is produced, it can be tasked with the problem of improving itself. Since it's a machine, it will likely do that very quickly by human standards. The improved version 2 can be asked to generate improved version 3, and in this fashion we might see thousands of iterations of improvement within a single human lifetime. Surely such a being would be evolved to be super advanced, yes? I suppose that depends on how you define advanced. First, you must assume that there is a clear definition of what it is to improve. What exactly is your loss function? Second, you must assume that you can efficiently compute the improvement that is needed to be made. Okay, everybody, right there is exactly why the show took up the theme of computational complexity in the last few months. The topic of artificial intelligence, I believe, is deeply and perhaps even surprisingly deeply intertwined with the topic of computational complexity theory. Asking a machine to take as input the description of a machine and a list of improvements you'd like to be done to it, and outputting a description of how to build the improved machine sounds a bit dubious to me. It's not quite the halting problem, but it's definitely adjacent. If we have machines with the property of artificial general intelligence, it does not necessarily follow that they will have the algorithms necessary to solve the tasks we give them. Just like human intelligence, artificial intelligence will be bounded by its own cleverness. Okay, so assume AGI is infinitely clever, whatever that means. It's still bounded by what's possible. Many of those results come from the complexity theory literature. For a moment, let's assume we have an AGI. We communicate with it through a chat window. One could say that this machine is like a programming language with a command line interface, which is just a compiler for the human language. Computer, devise a way to mill the rough lumber I've just bought into dimensional lumber, and give me the plans for assembling it into a beautiful dining table using a Penrose tiling on the top. Sure, an AGI could probably do that for me and draw me up all the plans I need to make my cuts. On the other hand, computer, resolve the P versus NP conjecture for me. Should set off many skeptical alarms. Any singularity we experience, any multiply exponential growth we may or may not see continue into the future, is going to be bound by the friction created in the complexity of the problems we attempt to solve. Belief in the singularity is a belief that rapid advancement will occur because every new problem will be trivially solvable by the latest and greatest iteration of AI. The idea that every problem confronted in the future will have an efficiently computable solution is honestly laughable to me. The singularity is a topic that, theoretically, we should cover extensively on Data Skeptic. However, beyond pointing out that we have extremely weak evidence to support the idea and that the default position is that we may or may not experience any such singularity, leads me to a point where I am not sure what else there is to say on the matter. Okay, let's start wrapping up. Last claim. Claim number 5. AI is already here, but it's being secretly used for some nefarious purpose. Much to my surprise, I have heard zero chatter from the conspiracy theory community on this one. For those people that can ignore mountains of evidence that demonstrate that we actually landed on the moon and still believe that the moon landing is a hoax, it doesn't seem like that far of a stretch to believe that the government is secretly controlled by some AI software. Throw in some jargon about blockchain and it seems like you'd be the new darling of InfoWars. It's weird to me that we don't have conspiracy theories about AI. I hope I'm not patient zero for that, but anyway, I'll be watching for these and other AI-related claims and trying to bring a perspective of scientific skepticism along the way. If you see any headlines we miss, feel free to send them our way. They don't have to be as extreme as the hypothetical conspiracy I just described. We won't necessarily be able to cover everything. What can't fit on the show will spill over into the blog, and the blog will be filled as time allows. Whatever the claims may be, burden of proof always rests on the person making the claim. People may say, our system is so complicated we can't explain how it works, but I assure you it has artificial intelligence. Okay, then pass the freaking Turing test in a controlled setting managed by an independent agency. But even beyond the Turing test, I'm reminded of that idea that Lance Fortnow shared on Data Skeptic earlier this year in our discussion of P versus NP. There's a steady pace of people claiming to have solved that problem, none of which have stood up to peer review so far. But if you can prove that P equals NP, as Lance said, it ought to be easy to get attention for your proof. Go mine some Bitcoin. Or go do any of the amazing things that you alone in the world, or at least, you having that proof, would be able to do with that knowledge. A similar argument is true of artificial general intelligence. If someone invents true artificial general intelligence, they possess a tool of tremendous power. Last week we heard a reading from Max Tegmark's Life 3.0. The first chapter is, in many ways, a story of exactly that. We heard an excerpt on the show, but the chapter goes on a bit longer, painting a very realistic image of how a world might be changed by such an invention. Let that be a blueprint to anyone saying they've solved AI but aren't getting the respect or attention they believe they're due. True AGI would be a gold mine, and if someone had it, we ought to know pretty quickly about it. Data Skeptic listeners, would a Master's of Science in Business Analytics be a big step forward for your career? Consider if the Mendoza College of Business at the University of Notre Dame could be the right choice for you. Their MSBA program will give you the tools and context to understand the transformational power of data. It's a 12-month program based in Chicago at their Michigan Avenue campus. It's a program to fit your life as an actively employed working professional. Find out more by visiting Mendoza, that's mendoza.nd.edu/dataskeptic. Let's talk about the core questions for this semester on Data Skeptic. I'm not going to answer these here, but I'll give you some flavor for what's to come. Why is conversation the focal point of the Turing test? What's so special about natural language? Disproving the possibility of AGI would likely require new physics. What theoretically might that look like? What methods might be used to achieve artificial general intelligence, and where do we need progress? What preliminary methods have AI researchers developed that are in use today? The pursuit of those core questions will span our regular interview segments and mini-episodes. We're launching a few new things in 2018, largely thanks to our generous Data Skeptic members. We're converting our newsletter into something I'm calling the Feature of the Week. Let's be honest with ourselves. How many newsletters hit your inbox in a given week? A ton, right? Do you read any of them? For most of you, you don't. I've seen enough of other people's tracking data on email campaigns to know this authoritatively. I'm overwhelmed by the volume of email lists out there and the amount of content in each one. Also that I can't consume a meaty newsletter all at once, and I don't want it sitting in my inbox. So we're taking a different approach. Our weekly newsletter is going to feature one and only one thing. If you like that thing, check it out. If you don't, it will be a satisfying fast delete as you move through your tasks for the day. No reason to leave it in the inbox and feel guilty later. Our solution to email newsletter deluge is the Feature of the Week. I hope you like it as much as I'm looking forward to producing it. Head over to dataskeptic.com and sign up for that. If you don't have enough Data Skeptic in your life, search for the Data Skeptic bonus feed in your podcast software of choice. I'm going to try and release more this year, and I've got a few random and fun surprises planned. If you're in or near Monterey/Seaside, California, I'll be speaking about AI at the 4th Annual Monterey County Skeptic Camp 2018 on January 6th in Seaside, California. I linked to that in last episode's show notes. There's a Facebook event for it. Everybody, next week is the jumping on point for this new chapter. We're going to start gentle and then go deep. Please point people to the show who might be interested in this topic. If you have something to say about it yourself, let's do that on Slack. And if you see claims about AI, please let us know. So if you walk away with just one idea from this episode, let it be that the default position on artificial general intelligence is that it's a very difficult engineering problem. We don't yet know how to build something like that. We're not sure if we have all the theory we need, but we seem to be making progress, and we have no reason to believe it's impossible. How far away is it? I think that's anyone's guess. But not epically far, I don't think. Enjoy the rest of 2017, and we'll see you in the new year. Between now and then, keep thinking skeptically of and with data.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.